Welcome, YouTubers, to another episode in my Grammar Heroes series. In today's video, there will be 7 tricky practice test questions that should prepare you for the Arithmetic Reasoning subtest of the Armed Services Vocational Aptitude Battery, that is the ASVAB, as well as the pre-screening Internet-Delivered Computer Adaptive Test, that is the PiCAT. In order to get the most out of this video, you'll want to pause the video after I read a question, attempt to work out the question on your own, and then resume playing the video to check your solution. As a reminder, you're not permitted to use a calculator or a reference sheet on the actual ASVAB or PiCAT, so as you work your way through these practice test questions, try not to use any of those resources. Finally, I want to point this out. Since these problems are considered very tricky, just do your best to understand how to solve these problems. That way you can recognize them in the future. In other words, don't say, I only answered 2 out of 7 correctly, I'm not going to pass this test. Again, these are very difficult and tricky word problems. Your odds of seeing these 7 questions back to back on the test are basically 0. As usual, I'll include timestamps in the description of this video. Next to the timestamp will be the topic that the question's testing, as well as a link to a video where I discuss that topic in greater detail. So if at any point during this video you feel as if you need more help, just look in the description, and there you'll find links to my additional resources. So with all those things finally being said, let's go ahead and get started with this practice test. All right, so this first question says, for his son's birthday, Jimmy plans to paint stripes vertically across the back wall of his son's bedroom. If he paints stripes that are each 20 inches wide and the length of the wall is 15 feet, then how many stripes will be painted on the wall? Assume there is no window or doorway in the wall that he is painting. All right, so for a problem like this, it might be helpful to make a quick sketch in an effort to visualize what's going on here. So according to the problem, we know that Jimmy is painting one of the walls in his son's bedroom. And what's more, we know that the wall itself is 15 feet long. In addition, we know that Jimmy is painting stripes on the wall. So he's going to be painting stripes vertically. And each of those stripes has a width of 20 inches. And let me go ahead and use multiple colors here so you can actually see this. So let's say he paints a green stripe here that's 20 inches wide. And then he paints a purple stripe here. And he just covers the whole back wall with stripes, all of which are 20 inches wide. Question is this, given that each of these stripes is 20 inches wide, and he's painting on a wall that is 15 feet long, how many of these stripes can he paint on this wall? Well, that's actually pretty easy to do. We're going to take the length of this wall, which is 15 feet, and we're going to divide that by the width of each of these stripes, which you should know is 20 inches. Now, here's where quite a few people would get stuck. They would say, well, how am I going to do 15 feet divided by 20 inches? Well, at some point, you're going to have to make a conversion. You're either going to have to convert feet to be in terms of inches or inches to be in terms of feet. As it happens, I think it's much easier to convert feet to be in terms of inches. And you should know that in 1 foot, there are 12 inches. So to convert 15 feet to inches, we're going to take 15 and we're going to multiply it by 12. All right, so let's go ahead and work this out very quickly. 5 times 2 is 10, so bring down a 0, carry a 1. 2 times 1 is 2, plus 1 is 3. Before you start multiplication with this, you have to bring in a 0 placeholder. 1 times 5 is 5. 1 times 1 is 1. Let's add this together now. 0 plus 0 is 0. 3 plus 5 is 8. 1 plus nothing is 1. So this 15-foot wall is actually 180 inches. We're going to be dividing that by the width of each of these stripes, which is 20 inches. And as it happens, this math is very easy to do. We can cross out these corresponding units, those go away, and then we can cross out these corresponding zeros in the numerator and denominator. So what we're left with is 18 over 2, and 18 divided by 2 is 9. So in other words, Jimmy can paint 9 stripes along the back wall of his son's bedroom. Again, assuming there is no window or doorway in the wall. So the answer to this one is C9. All right, so number 2 says a Cessna airplane is currently cruising at an altitude of 9,000 feet above sea level. Because of a storm, however, it begins to descend at a rate of 1,000 feet per minute and lines up with the runway to land. If the airport at which it normally lands is 1,000 feet above sea level, how long will it take for the Cessna to land there? All right, so many of you could solve this one mentally. You would say that the Cessna is 9,000 feet above sea level, the airport is 1,000 feet above sea level, therefore it has to descend 8,000 feet. 8,000 divided by 1,000 feet per minute is going to be 8 minutes. In the event you couldn't work your way through this one mentally, you could always make a sketch in an effort to visualize what's going on. So we have a Cessna, which is a very small plane, flying along at an altitude of 9,000 feet above sea level. Well, what does this above sea level mean? It literally means the distance the plane is above the sea. So let's say this is the ocean down here. We would know that this plane is flying 9,000 feet above the ocean according to the problem. In addition, the problem also told us this. The airport at which it lands is 1,000 feet above the sea level. So let's say the airport is right here and the runway is right here. Well, according to the problem, this airport is 1,000 feet above sea level. So the first thing you have to figure out is how much distance this plane has to descend in order to land at a runway that is 1,000 feet above sea level. So one way you could do that is like this. You could extend this out and you could extend this out. And in other words, you have to figure out what this vertical distance is right here. Well, we know that this line right here is 9,000 feet, and this line right here is 1,000 feet. So the distance from this line to this line is going to be 9,000 minus 1,000. 9,000 minus 1,000 is 8,000. So in other words, this plane's gonna have to travel 8,000 vertical feet to land on this runway. All right, and we know, according to the problem, that this Cessna airplane is descending at a rate of 1,000 feet per minute. So we're going to take 8,000, which is the total vertical distance it has to travel. We're going to divide that by 1,000, which is the rate at which it's descending per minute. And that's all we have to do. 8,000 divided by 1,000. If you can't do this mentally, you can cross out that corresponding zero, that pair of corresponding zeros, and that pair of corresponding zeros. 8 divided by 1 is 8. So in other words, it's going to take this Cessna, which is descending at an average rate of 1,000 feet per minute, 8 minutes to travel 8,000 vertical feet to land on this runway. So the answer to this one is B, 8 minutes. All right, so number 3 says the lengths of the sides of one triangle are 2/3 the lengths of the sides of a similar triangle. If a side of the larger triangle is 24 inches, how long is the corresponding side of the smaller triangle? All right, so it should be pretty obvious that in this problem, we're comparing two similar triangles. And if it's helpful, you can quickly sketch those out. In this case, I'm going to use right triangles since those are the easiest to work with in my opinion. And of course, it should be pretty clear that we have one big triangle and then we have another small triangle. In addition, we were told that the side lengths of the big triangle, one of the side lengths of the bigger triangle is 24 inches. So I'm going to say that the length of this side of this triangle is 24 inches. And according to the problem, we want to know how long the corresponding side of the smaller triangle is. Corresponding side means the same side. So we want to figure out how long this side of this similar triangle is. And in math, we typically represent unknowns with letter variables. Since we don't know how long this side is, let's call it x inches long. Well, this problem actually gave you a key that's going to make it very easy to solve. It says the lengths of the sides of the triangle are the lengths of the sides of one triangle are 2/3 the lengths of the sides of a similar triangle. So in other words, this side length is going to be 2/3 of this side length. So to figure out what x is, we're going to say x is equal to 2/3 times 24. All right, so as you can see, we're just multiplying a fraction by a whole number. One approach you can take to working this out very quickly is to write 24 as a fraction by placing it over 1. And when you multiply two fractions together, you simply just multiply straight across. So this becomes 2 times 24 over 3 times 1. And before working this out, you can actually simplify this. You can say 3 goes into 3 one time, 3 goes into 24 8 times. So this becomes 2 times 8 over 1 times 1. 2 times 8 is 16. 1 times 1 is 1. 16 divided by 1 is just 16. So we know that x, in this case, is 16 inches. And of course, that means that the length of this side of this smaller triangle is 16 inches. So the answer to this one is B, 16 inches. All right, so number 4 says, before the holidays, a jewelry store was selling 4 gold necklaces for $400 each and 12 silver necklaces for $150 each. After the holidays, only 1 gold necklace and 6 silver necklaces were left in the store. In terms of dollars, what was the ratio of the sales of gold necklaces to silver necklaces? All right, so for a problem like this, where there's a lot going on, it might be helpful to work your way backwards. So let's start with this last statement in this problem. It says, in terms of dollars, what was the ratio of the sales of gold necklaces to silver necklaces? So that looks like this. Dollars worth of gold necklaces sold compared to, again, when we talk about ratios, we always use the word to, the dollar amount of silver, if my pen will let me write it, necklaces sold. All right, so this is what this ratio looks like. Dollar amount of gold necklaces sold to the dollar amount of silver necklaces sold. So we have to figure out what those values are. Well, we know that gold necklaces sell for $400 each. But that said, we have to figure out how many of them were sold. Well, it says right here, before the holidays, there were 4 gold necklaces in the store. After the holidays, there was only 1 left. 4 minus 1 is 3, so they sold 3 necklaces. All right, so to figure out the total value of the gold necklaces sold, that's going to be 400 times 3. You should know that 400 times 3 is 1,200. So $1,200 worth of gold necklaces were sold. And if you wanted to, you could work this off to the side like this. 400 times 3. 3 times 0 is 0, 3 times 0 is 0, 4 times 3 is 12. That's how I got 1,200. All right. Now let's do the same thing for silver necklaces. We know silver necklaces cost $150 each. I wish they were $1.50. And now we have to figure out how many of those were sold. Well, according to the problem, there were 12 in the store before the holidays. After the holidays, there were 6. 12 minus 6 is 6. So to figure out the total amount in terms of dollars of the silver necklaces that were sold, we're going to do 150 times 6 if my pen will let me write it. This one's a little bit harder to do, so I'm going to work it off to the side so as not to make any mistakes. 0 times 6 is 0. 5 times 6 is going to be 30, so drop down a 0, carry a 3. 6 times 1 is 6, plus 3 is 9. So $900 worth of silver necklaces were sold. And if you look at our answer choices, you can see that 1200 to 900 is not there. And that's because we can actually reduce this ratio pretty quickly. Again, we can cross out corresponding zeros. So I'm going to cross out 2 zeros here and 2 zeros here. This becomes 12 to 9. And you should also recognize that 12 and 9 have a common factor of 3. In other words, I can divide both 12 and 9 by 3. 12 divided by 3 is 4. 9 divided by 3 is 3. So the ratio of gold necklaces sold in terms of dollars to silver necklaces sold in terms of dollars is 4 to 3, which you can see is answer choice B. All right, so number 5 says the price of gasoline is $2.27 per gallon and decreases at a rate of 3 cents every 2 months. Oil cost 45 cents per gallon and increases at a rate of 5 cents every 6 months. How many years will it take for them to be equal in price? All right, so this problem, in all honesty, is very, very challenging. So if you struggled with this one, understand that that was probably my intention when I put this problem in this video. That said, let's start breaking this problem down. And as you'll see, solving this one's not as difficult as it may appear at first glance. So the first thing I want to point out is this. We're told that the price of gas decreases 3 cents every 2 months. The price of oil increases 5 cents every 6 months. And we want to know in how many years will it take for them to be equal in price. So we're given 3 different rates. Decrease in terms of 2 months, increase in terms of every 6 months, and how many years. So to solve this one, the easiest approach you can take is to write both of these rates to be in terms of years. And that's actually pretty easy to do. If we know gas decreases 3 cents every 2 months, we can take that 3 cents and we can multiply it by 6, and that will tell us how much it decreases in terms of 1 year. Again, there are 12 months in a year. 12 divided by 2 is 6, so multiplying 0.03 by 6 will tell us how much it decreases per year. You should know that 0.03 times 6 is going to be 0.18. So in other words, the price of gas decreases by 18 cents per year. All right, so we standardize this first rate to be in terms of years, which is ultimately what this question is asking. Let's do the same thing for oil. Again, we're going to standardize it to be in terms of years as well, or 1 year. I shouldn't say years. We know that it increases at a rate of 5 cents every 6 months. Well, there are 12 months in a year. So if we take 0.05 and we multiply it by 2, that tells us that it increases 10 cents per year. All right, so now we have both of these rates standardized. If the price of gas decreases 3 cents every 2 months, that means it decreases 18 cents per year. Likewise, if the price of oil increases 5 cents every 6 months, that means it's increasing 10 cents per year. All right, so with that in mind, let's try to solve the rest of this problem algebraically, and let's let x be the number of years? All right, because that's unknown. We don't know how many years it's going to take for these two prices to be equal. So now we actually have to write we actually have to write an equation to express what this problem's asking. Um, the price of gas is 2.27 per gallon. So it's currently 2.27 per gallon. I got that right here. And it decreases at a rate of 3 cents every 2 months. Well, decrease means goes down, which is subtraction. And again, that 3 cents every 2 months is 0.18 cents per year. We don't know how many years it's going to take for these two prices to be equal to each other. So I'm going to write this as 0.18 times x. And we want this price of gas to equal the price of oil. Again, oil is currently 45 cents per gallon, and it increases 5 cents every 6 months, which is the same thing as 10 cents per year. Well, increase means adds. And again, that's 10 cents per year. We don't know how many years it's going to take for these two things to be equal. That is the price of gas and price of oil. So we'll go ahead and plug in x there. So by solving this equation right here for x, and let me go ahead and move down this next problem so we can have some more space here. By solving this equation for x, we'll know exactly when the price of gas, right here is the price of gas, will be equal to the price of oil. All right, so all we have to do is solve for x. The first thing I'm going to do is I'm going to add 0.18x to both sides. So this is going to be plus 0.18x plus 0.18x. This crosses out here. Again, negative 0.18x plus 0.18x is 0, leaving us with 2.27 on this side. And we have 0.45 plus, what is 0.10 plus 0.18? That's actually pretty easy to do mentally. 0 plus 8 is 8. 1 plus 1 is 2, so this is 0.28x. So this is plus 0.28x, if my pen will let me write it. All right, so we're solving for x, so let's move this 45 cents to this side via subtraction. This crosses out here, leaving you with 0.28x on this side. And let's go ahead and work on doing this subtraction here. 7 minus 5 is going to be 2. 2 minus 4 we can't do, so we're going to have to borrow. This is going to become 1. This becomes 12. 12 minus 4 is going to be 8. Drop down our decimal in place. 1 minus nothing is 1. So this is 1.82 equals 0.28x. Again, we're just solving for x, which refers to the number of years it takes for these two prices to be equal to each other. So let's divide both sides by 0.28 to get x by itself. This crosses out here, leaving you with x on this side. And all we have to do is work out this now. 1.82 divided by 0.28. All right, so now we're working with decimals, and we're doing long division with decimals more specifically. In order to proceed, we have to clear this decimal from the number that's outside the division bracket. So I'm going to shift it 2 times to the right. That's going to enable me to write 0.28 as 28. And I also have to shift the number inside the division bracket, the decimal in the number inside the division bracket, a corresponding number of times. So 1, 2. So this problem becomes 182 divided by 28. All right, so we start by asking ourselves this. How many times does 28 go into 1? It doesn't. How many times does 28 go into 18? It doesn't. How many times does 28 go into 182? Well, let's think about this. Let's say let's say this number was 30 and this was 180. 30 times 6 would be exactly 180. So I know 28 goes into 182 about 6 times, and I'm going to work that off to the side to see how close it gets. 28 times 6. Uh, 8 times 6 is 48, so drop down an 8, carry a 4. 2 times 6 is 12, 13, 14, 15, 16. So this is 168. 182 minus 168. 182 minus 168. I'm going to have to work that out the old-fashioned way here. Uh, 2 minus 8 we can't do, so we're going to have to borrow. This becomes 7, and this becomes 12. 12 minus 8, 8, 9, 10, 11, 12. That's 4. 7 minus 6 is 1, and 1 minus 1 is nothing. So now the question is, how many times does 28 go into 14? It doesn't. So we have to realize that there's a decimal here, which we can bring up to our answer, and a 0 placeholder after this number, which we can now drop down. How many times does 28 go into 140? Again, think about this like 30. 30 times 5 would be 150. So I'm going to say 28 goes into 140 about 5 times. And let's work that off to the side. 28 times 5, if my pen will let me write it. 5 times 8 is 40, so bring down a 0, carry a 4. 2 times 5 is 10, plus 4 is 14. So 28 times 5 is 140. 140 minus 140 is 0, so there is no remainder. So we know that 182 divided by 28 is 6.5. In other words, it will take 6.5 years for the price of gas to be equal to the price of oil, given this word problem. So the answer to this one is A, 6.5. All right, so number 6 says the odds of rolling a certain number on a single-sided die is 1 chance in 6 rolls. During a game, someone rolled 3 5s. According to the odds, how many times must that person have thrown the die? All right, so we know that certain number that they rolled is a 5. And the problem tells you right here, the odds of rolling that certain number, which is a 5, is 1 chance in 6 rolls. So to make this pretty easy to understand, let's go ahead and write this one out like this. Here's the first roll. They didn't roll a 5. Here's the second roll. They didn't roll a 5. Here's the third roll. They didn't roll a 5. On the fourth roll, they rolled a 5. Fifth roll, no 5. Sixth roll, no 5. So as you can see, out of these 6 rolls, they rolled a 5 once. Well, we got to figure out how many rolls they made in total to get 3 5s. So let's just copy this down again. First roll, no 5. Second roll, no 5. Third roll, no 5. Let's say on the fourth roll, they roll the 5 again. Fifth roll, no 5. Sixth roll, no 5. All right, let's say they start rolling the dice again. Let's say they rolled a 5 right out of the gate. And then on the second roll, no 5. Third roll, no 5. Fourth roll, no 5. Fifth roll, no 5. Sixth roll, no 5. So clearly, for each of these, they had 1 out of 6 odds of getting a 5, and they rolled 3 5s. The question is this: how many times did they roll this dice in total? Well, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So clearly, to roll these 3 5s, they had to roll the dice 18 times, which is answer choice D. All right, so number 7 says a boat can travel 16 miles up a river and against the current in 2 hours. The same boat can travel 36 miles downstream and with the current in 3 hours. What is the speed of the boat in still water? What is the speed of the current? All right, so a problem like this, admittedly, is very, very challenging. And if you're going to score somewhere between 90 and 99 on the ASVAB, something similar to this may show up. So it's a good idea to have a plan as to how you're going to solve it. I think the first thing I want to do in this problem is try to represent what's going on visually. So let's go ahead and do that. We have a boat sitting in a river. So here's our boat, and it's sitting in this river. According to the first part of this problem, it goes 16 miles up this river and against the current in 2 hours. All right, so the boat is going this way and it's going against the current. So here's the current. It's actually pushing against the boat as it tries to go upstream. All right, so we represented this first part of this problem. Additionally, we were told that the same boat can go 36 miles, so 36 miles downstream with the current in 3 hours. Right, so here's our boat. It's sitting in the river, and in this case, it's going downstream, which means that the current is going with it. And as a matter of fact, that means the current is actually pushing on the boat to speed it up. Clearly, it covered a lot more distance in 3 hours with the current than it covered going against the current. All right, so now we have to figure out what the speed of the boat is in still water and what the speed of the current is. All right, so you should recognize that you have all the elements of the distance formula. Again, according to my reference sheet, we know that we can find distance by taking rate and multiplying it by time. That is, distance equals rate times time. Clearly, we have a distance right here, notably 16 miles, and we have a time right here, 2 hours. Here we have a distance of 36 miles and a time of 3 hours. But in this case, we have this added variable of the current, and we want to know how fast that is as well. So we're first going to have to modify this distance, rate, and time formula. So let's work on doing that. And it's not as hard to do as you think. Let's think about how the current is affecting the rate of the boat in this case. So the boat is going upstream, so that means it's going against the current. So the rate of the boat, which I'm going to call R, is actually being slowed down by this current, which I'm going to call C. So to represent that algebraically, it's going to be the rate of the boat minus the current, because the current is taking speed away from this boat. All right. And in this case, we know that the boat is being helped by the current. So the speed of the boat, which is R, is being helped by the current, C. So we know that its speed is increasing. So this is going to be R plus C. So our new formula for distance, rate, and time has to account for this current, and it's going to look like this. Distance equals, instead of just having rate, we're going to have R minus C times T for this first scenario. And for the second scenario, we're going to have distance equals R plus C times T. All right, so we've accounted for how the current is affecting the speed of the boat in this problem. So let's go ahead and start plugging things in. We already know some of these values. We know that in this scenario here, the boat went 16 miles, so this is 16 equals rate. We don't know its rate, so we'll leave that as R. We don't know the speed of the current, so we'll leave that as C. And we know it took 2 hours in this first case for this boat to go 16 miles. So we know T is 2 in this case. All right, let's represent this second scenario algebraically. We know this boat went 36 miles, so that's going to be 36 equals, and again, we don't know R or C, so we'll just leave those as is, R plus C. But we know it took 3 hours to go 36 miles. So clearly, by solving this equation, or these equations for R and C, we'll know what our answers are. So the first thing you may want to do is take this 2 and distribute it here and here. And then you'll take this 3 and distribute it here and here. So let's go ahead and do that. This becomes 16 equals 2 times r is 2r. 2 times negative c is negative 2c. Let's go ahead and do the same thing here. We have 36 equals 3 times r is 3r. 3 times c is 3c. All right. And these equations look pretty confusing. So you should realize that all the values in this first equation have a common factor of 2. In other words, we can divide everything by 2 to simplify this. 16 divided by 2 is going to be 8. 2 divided by 2 is just 1, so this becomes r. And then negative 2 divided by 2 is negative 1, so this is r minus c. And you should recognize that everything in this second equation is divisible by 3. 36 divided by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. So 36 divided by 3 is 12. 3r divided by r is just r. And 3c divided by 3 is just plus c. All right, so now what we have is a very simple system of equations that we can use to solve for r and c. As a matter of fact, if you add these two equations together, watch what happens. 8 plus 12 is 20. R plus r is 2r. Negative c plus c is what? Negative c plus c is nothing, so c is eliminated. If we divide both sides by 2, this crosses out, leaving us with just r on this side. 20 divided by 2 is 10. Well, what is this r? This r refers to the rate of the boat in still water. Again, there's no c acting upon it, so we know that the boat goes 10 miles per hour in still water. All right, and given that we know that r is 10, we can quickly figure out the rate of the current by taking this value of r and plugging it into one of these two equations here. So we have 8 equals r minus c. We now know that r is 10, so we can go ahead and plug in 10 right there. This becomes 8 equals 10 minus c. Let's go ahead and subtract 10 from both sides to get c by itself. This crosses out, leaving you with negative c on this side. 8 minus 10 is negative 2. Divide both sides by negative 1 to get rid of this negative in front of the c. This negative crosses out, leaving you a c on this side. Negative 2 divided by negative 1 is just 2. So we can see that the speed of the current, which is c, is 2 miles per hour. So we know the rate of the boat in still water is 10 miles per hour, and the rate of the current is 2 miles per hour. And that is, as you can see, answer choice A. All right, so that is it for this video. As always, I hope you found it helpful. And as usual, you're more than welcome to leave feedback in the comment section below. If you want to help my channel out, please consider subscribing to it. In addition, if you think my content's helpful, please feel free to share links to my videos with others. And on that note, I'm going to go ahead and cut you loose.
こんにちは。